This is the new data acquisition system, so it will essentially replace the digital Lynx SX. So it's our newest higher performance multi-channel data acquisition system. It will double the current capabilities as far as channel count goes, to go up to 1024 channels. And we have also updated our Cheetah software in order to give a couple extra capabilities with this, which we'll go into later, but stimulation is a big one, and then as well as software referencing. So some of the core features of it are on the front panel. We have analog outputs. This is an increase from the SX to have more availability for customers to bring in analog inputs from other devices. We continue to have the real-time processing for both low frequency and high frequency signal acquisition. Continue to have TTL input and output to support external equipment. We also continue to have the audio monitoring, and then we still have the support for closed loop applications through outside software, typically MATLAB. This is the backplane. So you have the power, a ground to ground the system, SFP data links to connect directly to the computer or an external system for further analysis or during acquisition. We have another stream of data. TTL outputs are now on the back, as well as the analog input and output on the back there. And then the cover is for the SD card that holds the firmware for the device. Then on the front here, we now have HDMI inputs instead of the previous MDR50 ones. So we will have adapters for this to be able to connect current digital head stages to this for the digital acquisition interface board. Customers are able to use both 16, 32, and 64 channel head stages through one single port with sampling rates up to 30 kilohertz. This is common across all of the digital head stages. 30 kilohertz is the going sampling rate. Noise is between the 2.4 and 2.5 microvolts depending on the head stage, and then the 80 resolution is 16 to 20 bits head stage dependent. Intan based head stages, which are ones we currently have, are 16, and then the new iLinks will be 20 bits. And this will be compatible with recording and simulation head stages, full experimental control. So the iLinks head stage that will be coming out will be our version of the STEM head stage, and then Intan has a 16 channel 2116 that it will be compatible with. So then the analog acquisition interface board will be the next edition of the board. So this will go into the front of the board to be able to go back and forth between digital and analog head stages. Our current system, the Digital Lynx SX, has more analog inputs than others, or than digital. So this will continue to allow customers to have flexibility in their recordings and be able to do both, to have backwards compatibility with products that they already have. This will also have the stimulation support, the input range of plus or minus 262 millivolts, and the 80 resolution and noise will also be head stage dependent for that. Okay, so then those are pretty well the overviews of the hardware. As far as Cheetah goes, you will now be able to have the 1024 channels of real-time data acquisition. So again, doubling our current capabilities in Cheetah. Continue to have auto thresholding for spikes, signal processing for LFP, EMG, EEG, etc. We added new stimulation control, continue to have the noise reduction filtering. It's multi-threaded, so you can process large data sets, especially with the higher channel counts. Very configurable. You can move windows around depending on how the customer would like to view it and how they want to bank their channels. We did change the licensing for the new Cheetah, so it's banked in the number of acquisition channels you wish to record and upgradable to make it future-proof. We've increased the bank sizes, so it used to be in banks of 32 and now is in higher banks. There are less licenses for that. Okay, so then into the stim control. It will support the stimulation pulse output on 4 digital IOs or TTLs. And then the stimulation on 16 and 32 channel in tan head stages, the 2116s, and then the iLinks that will be in the future. So in this page here, you can see you can create multiple sim sequences. Depending on the head stage, you can list what output channels and return channels you want. We have different pulse sizes that you can do. And we wanted to make it user-friendly to be able for them to click through and be able to see what kind of pulses they're doing. And then you can either do a manual trigger or an external trigger through Netcom. You could code there to have an external trigger there. The other new feature for Cheetah would be the software referencing. So in previous revisions, we've had hardware referencing, which is generally a little bit more limited than the software referencing. We've had 8 references, and then as far as digital head stages go, which will be the first release of the DL Plus, will have a hard reference. So you don't have the reference flexibility that you have in the analog signals. So we've introduced software referencing in order to have a way to reference on the digital side, and also will continue to give you more referencing options on the analog side. The way that this is done in our setup is you can reference channels average together and subtracted from the affected channel. So you can use multiple channels and average them. You can use one channel and you can have essentially as many as you would like. We currently don't see a limit on the number of references or channels within each reference, but it would be dependent on the CPU resources. So as far as compatible products with the Digital Lynx Plus, we wanted to make sure that a lot of our existing hardware would be compatible with this. So the first one would be the commutator. So this would be 16 to 320 digital channels or 16 to 160 analog channels. It allows for unencumbered movement for animals during experiments, most commonly with rodents. It allows for the tethers to stay out of the way, helps protect the tethers from chewing animals, etc. And then you also can do a through-bore cannula for optical fiber or fluid delivery to the animal. Then for video tracker, we use the Baszler ACE camera pictured here. In order to synchronize the video data with neural and other recorded data, you can use up to 4 cameras on one system. Especially useful for customers either trying to get different views or for rodent customers that are running multiple animals at one time. You can also record with LEDs, get head position and tracking data there, dependent on what head stage you're using. So these are our existing digital mux head stages. This is an example of a 32 channel LED and then the 64 channel one. So these digitize the analog signals directly on the head stage. They can reduce the tether weight, size, and wire count. They have the sampling rate of 30 kilohertz and 16-bit resolution. And we have multiple length options, typically 1, 2, and 3 meters, although we make custom lengths as well. Compatible with Omnetics input connectors and with the digital interface board. So this is the new iLinks head stage. This is a prototype picture of it. But it will be able to stimulate and record on 32 channels with 3 references and a stimulation compliance voltage of plus or minus 8.5 volts. And then one of the 32 available channels can also be selected as a hardware reference. And then each channel can be independently stimulated and programmed waveforms in either plus or minus 50 nanoamps or plus or minus 200 microamps with a range of the 16-bit resolution. And then all of these channels and references are DC coupled input range of plus or minus 262 millivolts with a 20-bit resolution. So this will be a great increase to the current capabilities of stimulating head stages that are out on the market now. And then we will continue to have our unmatched service and support, so dedicated remote technical support, lifetime software upgrades, on-site service and training available, and then service agreements and access to knowledge base with expanding support articles,